So we saw from Newton's laws of motion that if we have a body here at rest, it will remain at rest unless there is a net force acting on the object. So right now there will be the force of gravity on the cart and then the normal force on the cart from the track itself. Those two forces are equal and are in opposite direction, therefore the net force here is zero. Now if I go ahead and apply a horizontal force with my fingers onto the cart then will accelerate because there is a net force. Now I have the pushing force, the normal force, and the weight. The normal force and the weight are going to cancel each other out, but now my pushing force would be the net force. Therefore, the cart is going to accelerate. That acceleration is going to equal to the net force. In other words, my pushing force divided by the mass. So therefore, the object accelerate. And as long as I'm applying the force here, the object is going to accelerate. If the pushing force is constant, the acceleration will be constant. Therefore, the motion or the velocity of the object is going to be changing. In this particular case, the velocity is going to be increasing to the right because the object is accelerating to the right. Momentum is another motion parameter. Momentum is simply the object's mass times its velocity. So we can write Newton's second law in terms of momentum. So as long as there's a net force, the velocity is going to be changing. Therefore, since momentum is the product of the mass times the velocity, if the velocity is changing, then the object's momentum is changing as well because the mass times velocity is changing. So I can write Newton's second law a different way. I can say, hey, the net force acting on the object is going to change the object's momentum. And the rate at which the momentum changes will be dependent on my pushing force. Okay, so as long as I'm pushing, the velocity change, the momentum is changing. The rate at which the momentum change will depend on the net force on the object. But if there is no net force acting on the object is not accelerating, the momentum is not changing. In other words, the momentum is constant. For example, here, the net force is zero, the object's velocity is not going to change, the momentum is zero, right? Now, if I push the object, give it a non-zero velocity, it begins to move. If this was a completely frictionless track, the object is going to keep on going with a constant velocity. The momentum then, which is the mass times the velocity, will remain constant because the net force is zero. So if we can take a look at a system where the net force on the cart is zero, then the momentum is not going to change. In other words, momentum is conserved because there isn't a net force to change the velocity of the object.